My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family, I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GlowCloud team.
Welcome, everyone. Today we are here to talk about BGP, or the Border Gateway Protocol. And for me, BGP is something I built my career on starting 25 plus years ago. It's a routing protocol that I love, that I've worked with in every possible wacky environment you could think of. And it's a great protocol. Now, we're here to talk about BGP for cloud architects. Whether you're dealing with AWS, you need BGP. Whether you're dealing with Azure, you need BGP. Whether you're dealing with Google, you need BGP. So Mark and I are going to talk about what is BGP, why we use BGP, how BGP works. We'll get involved into the messages. We'll get involved into the finite state machine. And then we're going to save the best for last. Mark and I are going to do some traffic engineering exercises, because the whole plan of BGP is to create policy-based routing, load share, and all kinds of great things. So Mark and I are going to do that. And again, I just love BGP. So let me know you're here. Give me a hashtag BGP for cloud architects, and we'll go. Now, obviously, if you want to be a cloud engineer, BGP matters. If you want to be a network engineer, you can't get away with it without BGP. So for any cloud architect, network architect, it's going to be critical for what we actually do. So we'll begin in about 2 minutes. I want Mark to basically introduce himself. Mark is our Chief Technology Officer. Mark knows BGP real well, too. Mark is also a Cisco certified internet expert, although we did it like at very different times. Mark, when I look at my CCI number, it almost makes me feel old. When I look at Mark's CCI number, I see someone that's an expert on technology and someone that's really still doing it every day. And we're going to have lots of questions for Mark here. Mark, you want to introduce yourself and talk about a few things before we begin?
Sure. As Mike mentioned, my name is Mark Milovanovic. I am the CTO of Go Cloud Careers. About a decade or so in networking. That's my primary domain. Of course, there's some security, some data centers, some voice over IP, all the little things that get kind of meshed together, because you can't avoid it if you become a senior network engineer or architect, because you're going to be interacting with the different components of the system. But aside from that, like Mike says, once you go down the rabbit hole of networking, it seems like BGP is the answer for anything and everything when it comes to networking. Even though we won't be going into the 15 or 20 different applications of BGP outside of IPv4, just know that this is going to be a foundational workshop. So we're going to be discussing things such as what is the Border Gateway Protocol to begin with, just kind of like a little refresher. We'll touch on some reasons why would you want to use BGP, and then we'll get into some of more the technical details in regards to what is the finite state machine at all? Why is that important? We'll look at some of the different messages that BGP uses to communicate between one autonomous system peer and the other autonomous system peer. And then we save the best for last. We're going to look at some scenarios in regards to how do we take these attributes, these characteristics of these different routes that BGP can learn, and how do we manipulate them to accomplish a particular policy? Because in the end, BGP is a policy-based application or some people might even argue that it's a routing protocol. I'll leave that up to argue between all of you here. If it's an application, if it's a routing protocol, everybody has their own opinion. But before we get going with that, if you are interested in a little bit more networking related items, we just posted part 1 of our CCNA bootcamp. I believe if I saw it was over 10 hours of fantastic content, gets you a little bit up to speed in regards to networking. So if you have no experience in networking, you don't even know what a router, what a switch is, if you have no comprehension in regards to how host-to-host communication happens, you definitely want to take advantage of that free resource. And we'll have the link in the description box and as well in the chat box. Now, if you want to, go ahead, Mike.
One more thing before Mark goes on. There's actually 30 hours of this full CCNA program. We released the first 10 hours today. 10 hours are going to come out free tomorrow, and the next 10 hours are going to come out free the next day. Mark, go back to what you were doing.
Yep. So basically, this is just part 1 of a multi-part series that we have planned for everybody. Aside from that, you'll notice it'll be in the description box as well as the chat box. There is a free BGP guide that you can download. The beauty about this type of guide is if you download it right now, you sign up for it, you get the guide. Hopefully you get it in time as we get started. You can use it as almost like a little cheat sheet in regards to what we're going to be discussing. And that way you have multiple kind of sensory stimulation. One is where you have visual, audio, and then you can also read. So it's always good to look at these type of things. Additionally, and this is something nice, while we per se, we won't be doing a 6-hour BGP WordCamp or whatever it was last time, so we're not going to do that today. But as a thank you for showing up here, there is going to be a link in the description box as well as the chat box in regards to 5+ hours of just BGP walkthrough videos in regards to different scenarios. These can range everywhere from what is external BGP. We're going to go through some of the details in regards to internal BGP and how the split horizon rule kind of fits into that. There's some additional little bonuses that we threw in there in regards to how do you do fast failover detection using bidirectional forward detection. And of course, we actually have a lab breakdown that shows you how you can use and manipulate the different attributes in regards to BGP. Now, the focus of the lab is not to teach you the configuration, but rather you will see the configuration, how it is done, with the intent to see the outcome, because that's what's going to be critical as an actual architect. It's not the configuration, but to understand is if something is designed and then eventually implemented by your networking team, what are the actual repercussions or the consequences, either good or bad, of your actual configuration and your design. So you'll have 5+ hours of that. I think everybody's going to enjoy that very much. We're going to go through everything from weight to local preference to multi-exit discriminator, you name it. It's going to be a blast. And we'll also have a little bit of a Q&A session kind of dispersed in between today's BGP bootcamp. And then finally, because that's something that I definitely look forward to every week that we have, is Mike and I, we get together. Generally speaking, we do it on a Wednesday in the middle of the week. We do a question and answer when it comes to anything related to career development. So it doesn't matter if it's networking, if it's cloud, if it's security, if it's you attempting to get your first cloud architect job, whatever it may be, you're welcome to join us tomorrow as well with a minor adjustment, which instead of being at 2 p.m. Eastern time, which is our normal time, we're going to launch it at 11 a.m. Eastern Standard Time. So just a little bit earlier, but hopefully you'll have your cup of coffee with you, ready with your questions. And Mike and I are going to look forward to answering those questions. Now, outside of that, I hope everybody is primed and geared for the BGP workshop that we're going to have in a couple of seconds. And I encourage everybody, as you listen to Mike, and then eventually Mike and I will have a discussion about BGP, think about some questions that you might have. And if you can, try to keep them within the scope of what we're discussing. I know it gets tempting to want to discuss layer 2, layer 3 VPNs and different control planes, how BGP is functional there, but let's try to keep it in scope. If you are interested in certain things, let's say they go a little bit out of scope. I know some people are probably going to be ecstatic to ask about some security measures. I have some things prepared for everybody where you can get some additional resources in regards to BGP security. But outside of that, everybody, I hope you enjoyed the session today. I'm stoked for this. BGP is also one of my favorite topics, such as Mike. And as they said, if you're going to get into networking, sooner or later, BGP and you will cross paths. There's no way around it. Not the case. Enjoy the session. Mike, I'll hand it over to you.
Sounds great. We're going to get started in our BGP. 2 more things I want to note. On Thursday, we are going to have our free webinar on how to become a cloud architect, where we will go over the role. We'll talk about what we do. We'll talk about the skills you need. It'll be free. It's live on Zoom, so you can ask any questions you have, and we will happily guide you on your career, literally any questions you have related to yours. And of course, continuing more networking, we have Russ White on our channel this week. He's an icon in the networking world, one of Cisco's distinguished architects. And to put that into context, out of 80,000 people, there were about 350 of them. So there's not many of them out there that have been around that long. He was a very incredibly respected peer at Cisco when I worked with him, and everywhere else he's gone. So we're networking stuff, and it's all free. Okay, let's talk about BGP now. So what is BGP? BGP is what we call an exterior gateway protocol. And exterior gateway protocols connect you to external entities. And when we deal with the world of organizations, what they typically do is they have a single set of routing protocols internally, and then they have another set of routing protocols that we use externally. So let me show you what I mean by this. Let's say, for example, we're inside of, this is a company A. And company A, inside of their organization, they run an interior gateway protocol like OSPF or intermediate systems to intermediate systems. And that's how all the devices inside of the organization communicate. Now, these interior gateway protocols that we actually used are used and optimized for speed. Cable gets cut, they detect it very fast. So these types of protocols give a lot of information to the router so they can make very fast reactionary decisions. Now, understand, when you design something for speed and you design something for performance at speed, you're not typically very scalable that way. I mean, a Ferrari is real fast, right? But I mean, how many Ferraris can you cramp the highway with, and how much stuff can you put in the trunk to trail it? If you needed to get a lot of things from point A to point B, you wouldn't take a Ferrari. You might take a tractor trailer. And why? The tractor trailer is not going to have the same performance because it can't. It won't have the speed because it can't. But that thing will go for hundreds of thousands of miles, and it'll take capacity that the Ferrari couldn't because it's designed for it. So interior gateway protocols are designed to be used inside of an organization, and exterior gateway protocols are used to connect to organizations. Now, understand, in these private organizations, we don't have a lot of tunability or any things that we can, very many things we can do with our protocols to change the way traffic gets pushed through our system. There's a little bit we can do, but generally speaking, information is sent to everybody. Now, if company A wants to talk to company B, they don't want to participate in the same routing. Company A wants to somewhat secure itself that if somebody at company B made a major mistake, their whole systems at company A don't go down. So what we use is a protocol that can connect these two types of devices that gives us the ability to filter things and control what we use. So with BGP, we can say company B only learns about these two subnets. Company A only learns about the two subnets they need to reach, and everything works. So that's typically what we're talking about when we're dealing with BGP itself. We're using it specifically for the whole purpose of communicating in between entities for the most part. So we use BGP because it scales incredibly well. You go to a core internet router and it has 900,000 routes on it. And that router with 900,000 routes might be getting those same 900,000 routes, albeit a little bit different, from 10 different internet service providers. And they've got to be able to build a routing information base of all this stuff and figure out which path it's going to choose. So that's why we use BGP. It's scalability. You're not going to put 8 million or 800,000 routes in OSPF. It's just not going to work. The CPUs on these devices would be so big that poof, and they would be crashing. And I remember the early days where the CPUs of the routers couldn't handle all of the OSPF information, and they would crash. We had the same problem with EIGRP many years ago. You only had a certain number of routes in it. The CPUs were very small. You'd get a link flapping a couple times. The CPUs in the router would hit 100%. And if you're old enough to remember the EIGRP stuck in active networking states, it was usually related to that. So that's why we're going to use BGP. Control, security measures, limited, and the ability to determine how we want our traffic to actually go. Now we're going to talk about BGP and how it works. So BGP is a routing protocol. And a routing protocol will tell you exactly how to find your destination. And it's specifically used for exterior connectivity. So we have two opportunities in routing, and I want you to think about which would be efficient. I have one opportunity where I would go to every single router I have in my network, and I would manually put a route on them. So if I have 5,000 remote locations, in each one of those 5,000 remote locations, I'm going to have to put a route to the central site if I had a hub and spoke environment, and the hub site or the hub sites would have to have routes placed in them to all these routers. So in the end, I'd be manually assigning routes all day long. Now, if I manually assigned all these routes, I go here, 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 and then a link went down, well, now I've got a big problem because traffic is going to be sent to places that no longer even exist anymore, or they're just going to be dropped, and then nobody will reach anything. If any of you remember the old-fashioned map books and the old-fashioned maps, when you were going to go to one of your friends' houses or you were going to go to a business meeting and you printed out a map, go 2 miles on I-95, make a right, make a left, make a right, make a left on northbound 1 for 10 miles. And I did it all the time, and it was just great, right? You planned out your directions, and all of a sudden the police would be rocking a road. Or it was Florida, so a hurricane would knock over a tree. And now you don't know how to get to your friend's house. How are you going to get to your friend's house? The road is blocked, and you don't have any other paths. And the reason we started moving towards GPSs, one of the many reasons, is they were adaptable. They were dynamic. A tree gets cut down, you push a button, it says reroute, and it takes you to your destination. I used to get lost a lot. I still get lost a lot. But I get lost a lot less with my GPS. I joke that my GPS needs my GPS to ask for directions, but still, the GPS is keeping me from getting lost. So that's why we need these dynamic routing protocols to learn all the routes or the subnets that exist, or aggregate routes that exist, so we can send our traffic there. And these routing protocols build a map of the network. If you want to go to this subnet, take this interface. If you want to go out that subnet, take this interface. If you want to go out this subnet, take that interface. So that's kind of what we're talking about. So the routing table gets built, and the routers use that information to get there. I'm going to talk about some BGP basics, super entry-level basics, and at some point we'll see if you've got any questions, and we'll go into several other topics. One thing that you need to understand is that most routing protocols send multicast hellos and form neighbor relationships that way. So whether it was RIP version 2, whether it was IGRP or EIGRP, OSPF, they're basically all sending some kind of a hello message to their neighbors in most cases. Are you there? They form an adjacency or a relationship. No, not so much with some of those older distant vector protocols, but in some of them, but they at least talk to each other in somehow. In OSPF, the two neighbors come up. They basically start exchanging information, and at some point they get full of information. Then they run their shortest path first calculation. So we've got to get our information there. And that's why we do this. But the reason BGP is unicast is if I want to connect with Mark, I say, Mark, I'm going to initiate a session with you. And Mark's going to reply to that session, and it's just between me and Mark. With other routing protocols, I stick a router there. And if it's on the same subnet and the routing protocols are there, it's just going to start participating in routing. I want to make that clear. With the other routing protocols, if you're on the same subnet running the same routing protocol, that router will automatically pick up the routing. So if we go back to this scenario over here with company A and company B, where if this was not BGP between them and this was OSPF between them, they'd exchange full routing information between them. But maybe company A only needs to access the servers on a single subnet of company B, and they don't need access to all those other routes. That's why we're using BGP. Now, BGP is a TCP-based protocol. I have to initiate a session with Mark, and we go through that TCP session formation, and then we'll do other things. And we're going to talk about all those other things soon. And we'll get to have some fun in traffic engineering last. But we're going to talk about how BGP forms a neighbor relationship and everything they do. So we're going to get to BGP messages next. Does anybody have any questions thus far? Because if so, I'm happy to answer them. If not, we're going to get to the BGP message types.
I believe everybody is still getting a little bit warmed up here, getting some of the juicy details.
because we're going to talk about the BGP finite state machine and all kinds of fun stuff. BGP for traffic engineering, BGP for cloud networking, and other environments. Heck, if we want, we can even talk about, BGP for like transit gateways, that kind of thing. All right. I don't think we have any questions. I think we're doing good so far. So let's get back to the content. So now we're going to talk about the messages that BGP uses. And BGP will use various messages to communicate with its neighbors. And we're going to talk about these messages, which are basically going to be an open message, which we'll talk about what that is, a keep alive message, an update message, and a notification message. So let's first talk about that open message. So if Mark and I were BGP peers, we first have to establish that TCP session. And you know how that works. I send a TCP SYN. Mark acknowledges my SYN. He sends a SYN or open a connection with me. I acknowledge it. And now we're able to talk to each other. So that has to happen first. So as soon as that TCP session is established, both neighbors are going to want to send what they call an open message to each other. And in the open message, then the routers will be able to see and identify each other and their BGP parameters. The open message can include a lot of information. For example, which version of BGP are we using, i.e. version 4? The autonomous system number, your autonomous system number, or their autonomous system number. The hold time, which is basically the maximum number of seconds that can elapse before the router must either receive a keep alive or an update message, or it thinks there's a problem like the session is torn down and it needs to do something about it. That open message typically includes a BGP identifier, which is either you put an identifier in there, or you make it the loopback address or something of that router based upon what you're using. So that's to open it up. Now, for many of you who are familiar with health checks in load balancers, and routing protocols need to run their own types of a keep alive, because how are they going to actually know if their neighbor's there? So what will happen in this environment is if we have two BGP routers, let's say this is me and Mark, and we're running BGP between us, Mike, Mark, and we've got a link between us. So if I'm up and Mark's up and we're talking to each other and we're exchanging routing information, this is really great. But if Mark goes down, that might not be great, especially if I have more than one path that I could actually take to get to my ultimate destination. So let's say my preferred path, let's do this. And this is we're going to show why we need these keep alives. Let's add some more names over here. Cindy. Let's add Sunny over here. Chris's cat's name. So now if this is my path, and my goal is to get to Sunny. But note, I've chosen to make this pipe look a lot bigger for whatever reason, and I want my main traffic to go between me and Mark. I don't want to go from Mike to Cindy to Sunny. I want to go from Mike to Mark to Sunny. And my BGP policy has it set up that this is going to be my preferred path. Now, what happens if Mark goes down and I start sending traffic to Mark, who's no longer there? We lose everything. We lose everything. So I need to know when I've got more than one option, especially, that if Mark's not there anymore, I can take my backup path through Cindy. So what happens is these devices, they run a health check. And in this case, the health check is called the keep alive. I send a keep alive message to Mark, like every 10 seconds or whatever our timers are set for. Mark, I'm there. And Mark sends me a message. Hey, Mike, I'm here. And I send Mark a message. I'm here. And then Mark doesn't respond. And I send another message to Mark, are you there? And he doesn't respond. And I don't get a message from him. At some point, I need to tear down that BGP session. and then I start sending my traffic over the other path. So that's why we need the keep alive session. Now, if you've ever worked with a load balancer and they run a health check and they basically ask the server, are you there? And the server responds, and they ask another server, are you there? And they respond. And then one of the servers doesn't respond for a few health checks, and all the traffic is sent to the good server and the bad server is marked unhealthy. Or how DNS runs health checks on remote locations so it knows how to send half of your data to AWS and half of your data to Azure. It's the same concept with the BGP keep alive. Now, there's another BGP message that's going to be called an update message. So let's talk about what that is. So I'm connected to Mark, and I learn a new route or a new prefix. I send an update message to Mark. Here's the new prefix I learned. Meanwhile, Mark saw some internet prefix that he had in his routing table go down, and he sends me a message to say, look, we got to withdraw this route. And in many times in these update messages is add these 10 routes, remove these 5 routes. But that's how the routers keep in charge. That's how they keep up to date, as they send these update messages to each other. So if we go back and we talk about these, the open is to say, hey, are you there? And identify each other, the other router. The keep alive is to say, I'm here, are you here? It's a health check. And an update message we send when we need to add new routes or remove new routes. And what are we getting? We'll call it network layer reachability, which is basically a route. But in these update messages, we're also going to get something that's very important, the BGP path attributes. And get ready to get geeky. The BGP path attributes are our fun nerd knobs. And they always called them nerd knobs. And honestly, it still rings true. We're going to get exciting and have fun with that. We're going to do that in the end, though. So we're going to make you learn the fundamentals first. And then they'll also talk about, obviously, the routes withdrawn. So now let's talk about a notification message. So, all right. So open, hey, we're up. We're identifying each other. Keep alive. Hey, are you there? Are you there? Health check. We talked about an update, which is good stuff that we're sending. Now, the next thing is the notification message. And let's face it. Do you ever like to get notifications of anything? Notifications are generally not good news. So in a notification message is sent in BGP whenever an error is detected. So notification, not a good thing. We got a problem along the way. For example, if we in the notification, we may have a notification message if that we can't get to the same BGP version between routers. If we get something wrong, we get a notification message. So keep it in the back of your mind that this is generally not a good thing. Open, who are we? Update, so open, update, keep alive, health check, are you there? I just want you to remember these and why. So then we send an update when we have more information to share, and a notification is when things go wrong. This is not the best situation when that's there. So the next phase is the BGP finite state machine. The fun stuff is going to be the traffic engineering. I think I see a few questions in here. Let's check.
Yep. Let's go take a question that came in. So from Raja, they're wondering, when OSPF or BGP are running on a router, does the same port communicate using OSPF and BGP at the same time in addition to routing traffic? So Raja, BGP will use ports. So as Mike mentioned, it will use port 179 using TCP as the transport protocol. Now, there is a difference when it comes to OSPF and BGP. As it was mentioned, BGP doesn't have its own reliable transport protocol. And that's why it's using TCP to allow for synchronization, for retransmission of packets, things like that. While EIGRP, OSPF, what they actually do is they have their own routing stack that runs on top of IP. So generally speaking, what you will see is, let me see if I can show you this. Let me see. So if you can maximize my screen, that'd be great, please. And then I will show you. Yeah. So I hope, is this relatively clear for everybody to read?
Yes, if you know what to look for, Mark, it's going to be very clear.
All right, so let's do this. So what we're looking for here is this idea. So I'm going to look at just the simple OSPF packet. So this is going to be the hello packet, meaning I already established some type of neighborship. If I have not, I'm going to be looking for one. So what we're going to be looking for here is, and let me take out, is that this is the IPv4 header, but within it, there generally is this option available, which tells us what the next upper layer protocol is going to be. In this case, with OSPF, it tells us it's going to be protocol code 89. So that's going to be the code that it's going to be using when it provides its own transport. And we can see that as we open up a little bit further. In regard, oh, I did not mean to open the console. Sorry about that. Shortcuts get all messed up. But as you can see, is protocol 89, and then the OSPF header starts. Now, to show you the difference here is if we look at BGP, first what you'll see is, before we get to any BGP messages, is that we're trying to create a point-to-point TCP connection. That's what we're trying to establish first. And you can see that our first area that we want to look for is going to be our IPv4 header. Within our IPv4 header, next we're going to look at what is going to be our protocol ID. In this case, it's going to tell us the next protocol is going to be TCP, which is basically going to be code 6. But here's the interesting part. So if we now look at actual BGP found within TCP, you'll notice that it tells me my source port is 37,019. So I have no idea what that source port is, but what I do know, it is just some random higher port that I can use whenever I want to. We call these ephemeral ports, meaning I can use them once and then they get discarded. But here's the interesting part. Destination port 179. And that tells us specifically that we're looking to send this packet through TCP to somebody that's going to be listening on port 179. And so far, we actually don't see any additional, because, you know, as I scroll, any additional headers. Now let's go to the BGP header though here, which is going to be our open message. And let me close a little bit this for you. We're going to start again with IPv4. We got our IP addresses, source and destination. Our upper layer protocol is going to be TCP. And now when we look at TCP, it will tell us again, source port is 37,019. Destination port is 179. But here's not going to be the difference. Look at this. There's BGP. So in this case, it's an open message. So if we flip back and forwards, what you'll notice is that this is IPv4, OSPF. Here we got IPv4, TCP, and then BGP. So from a perspective just on how these two routing protocols actually operate, you already are going to see that there is a difference in what actual routing stacks they're going to be using or what type of upper layer transport protocol. OSPF, ERJTP have their own, so they can provide their own reliable transport, and BGP is going to be using TCP. Now, you also mentioned, though, and if we can put the question back up, if you don't mind, from Raja. I believe he mentioned in regards to if they're running on the same thing, do they use the same port? No, we mentioned that. Now, when we're looking at the actual routing the traffic, now this is where the difference comes in. What I just showed you was simply what we call the control plane, basically the brains of the operation. This is where we're going to be exchanging the information of any type of layer 3, we call them network layer reachability information, which is basically the route, and then the prefix length, which is basically your network ID, and then your subnet mask, as some call it. But BGP, you'll have to know it's actually the prefix and then the prefix length to make that up. In this case, we're just talking about the brains. We're just building the actual database of the different routes that we have available. When it comes to how the actual traffic is routed, that's going to be up to the actual equipment that you're going to be using. Cisco has its own proprietary Cisco Express forwarding, where it can kind of piece together the different databases, some called routing table. BGP has its own type of database. It has actually about 3 different databases, if not a little bit more. And what it does, it kind of takes them all together. It does some calculation on the back end too for some speed and performance. It does also layer 2 calculation of the header, so it knows what outgoing interface I have to take. But all of that is not actually done by any of these routing protocols. It's done by the actual router, or if you have a multi-layer switch, it's done by the switch itself. So there's going to be a distinction between the brains of the operation and then the bronx, or the muscle, which is going to be the actual device and what it actually does on what we call a line card, basically those ports that are going to be attached to the actual router or the switch. So what you're going to hear us predominantly discuss today is going to be the brains of the operation, this control plane on how BGP actually creates these sessions between each other. We call them peering sessions, the messages that are being exchanged, as Mike already mentioned, and then also how do we control the different characteristics of the actual routes as we ingest them or as we try to output them or we try to re-advertise them to other neighbors. I hope that answers your question there, Raj. If you have any follow-up questions, be sure to ask them, and we'll try to answer them for you. Let's go on to a couple more questions. So from Renato, nice to see you, Renato. They're wondering, how does the autonomous system number work and how to manage this autonomous system number? So I'm going to give you my version of how they work and how do you manage them, and then I'll let Mike go ahead. So autonomous system numbers, I think of them basically like country names, because I'm looking at the large picture of things. An autonomous system number is basically just an identifier that says that this is part of what I'm managing. In this case, we're talking about what? A networking domain or a routing domain. So in that sense, it's an identifier. Now, because BGP is actually used and the only protocol that we use for global routing, it is something that we have to predominantly register if we want to be participating in the global routing table. Now, there are also what we call public and private numbers. It's very similar to when we have public IP addresses and private IP addresses. Some we can use because they're going to be globally unique up on the internet, and other ones we can use internally in case we don't have our own provider independent IP address space, which basically means we don't own our own IP address space. So there's no reason really to go all out and go to one of the internet registry, or in this case, I believe, see if I remember who it is. It's not APNIC. If it comes to me, I'll mention it, the actual governing body that you have to go through, fill out a bunch of paperwork and pray and hope that they'll actually give you one of these numbers. So, but you will actually manage it through one of these different regional entities. For some reason, the actual name now escapes me. I'll put it in chat when I remember. But that's basically, you'll manage it through them, and how they work is it's just an identifier that eventually, as Mike will go through the session, Renato, you'll start discussing something what we call the autonomous system path and how it's a characteristic, or as Mike will refer to it, an attribute of the actual routing information that gets either ingested or eventually propagated through all the various larger networking domains, which we call autonomous systems. But that's just my take on it. What do you think, Mike?
So I'm going to leave that what Mark took, but Renato, I want to say this to you. I was so excited to get your message this morning about your official first cloud architect job. Congratulations again. Renato, you've always been a rock star, and I'm excited to see you in this new role. So congratulations, Renato.
All right, let's take a look and see if we have any more questions. So how about route refresh messages? So Cloudy, that is actually a additional message type. I actually don't have the RFC, which is the official technical document for it. But one of the reasons the route refresh message was actually created was that we wanted to have a way of refreshing our BGP tables without actually having to tear down our session and then having to reestablish it. It might sound trivial, especially if you're in the lab and you have a couple of routers. I mean, you can even have 50 routers in a lab. It will come across as trivial. But the reason it is not trivial in a production environment, and especially when we're now interfacing, let's say, with another service provider. Now, we don't have to be a tier 1 or tier 2 service provider. We could simply be a customer. that connects up to a service provider. And by the way, so everybody understands, tier 1 service provider, they have a full view of the entire global routing table. You're talking, I think it's over 1 million easily IPv4 routes, and then IPv6, I think we're creeping up to 600,000 or whatever it is. So what the route refresh allows me to do is, instead of breaking down the session, I'm going to send a message to my neighbor. I'm simply going to say to them, you know what, can you just resend me the view that you have of the routing table? I just want to kind of make sure that my policy gets applied the way it should be. So all it does, it comes in and it does a specific refresh only within one of the BGP tables or within one of the BGP databases. But the actual connection to each other stays up. Otherwise, what happens is if you do tear the session down, let's say you don't use the route refresh message, or it used to be soft reconfiguration, but if you don't use that, and let's say you tear the session down, and now let's say you're only ingesting, let's say 100,000 routes. Now, this is what many people don't know, and we haven't gotten yet to the actual BGP best path selection process, but the BGP best path selection process actually has to run per prefix. So that means I have to run that particular process on my CPU in my router 100,000 times just to process it. Then I need to be able to actually store that information. I need to be able to store my prefix length. I need to also put some memory aside for my actual attributes, my characteristics, including communities and other things. All of that takes resources. So now you can imagine something that might take 10 seconds, 15 seconds in a lab. What if you're sitting there and you're one of the transit providers, meaning you're a man in the middle that kind of facilitates traffic between one entity and another entity, or if we're going to keep with technical jargons today, one autonomous system and the other autonomous system, let's say between AT&T and Verizon, for some reason you found yourself in the middle, and all of a sudden one of those connections goes down because you didn't do a refresh, but you tore it down and you recalculate. Next thing you know, you cut off probably half of the West Coast because you forgot to add a soft configuration or soft command at the end of your BGP refresh. And that's going to be one of those problems. It can take minutes, 10 minutes, 15 minutes, 20 minutes. It could depend. But at that point, what you have just done, but not you using the route refresh message, is you have what we call in the industry so endearingly, you have created a resume generating event, which just basically means you're just about to go find a new job because you didn't use your route refresh. Mike?
Imagine a company offers 5 nines available service to their clients, meaning 5 minutes and 15 seconds of downtime per year. And you reset an entire TCP connection between these routers, and it takes 20 minutes. That they're no longer 5 nines. And you've already eaten up basically 50% of their 4 nines availability. So they're going to be paying a lot of SLAs. So, that's why we came up with this, because in an environment with 1 million plus routes, things get there, especially when you're connecting to 10 different providers and have sessions everywhere. So thank you for that, Mark. Claudia, great question there.
Yeah. And let's take one more question, Mike, before we get back to the content. And this is from John Doe. They're wondering, what do BGP attributes do? First, I want you to think of BGP attributes just like characteristics that you have. Sometimes we can say a characteristic is that you have a certain behavior. You have a certain speech pattern. Some might even say that your eye color is a characteristic, the shape of your nose, your mouth, the way you smile. In BGP terms, this basically means that there are specific things that you can almost say uniquely identify or provide unique characteristics to a particular route. And what they do in this sense is they provide us almost like just things that we can call upon or change and manipulate, just like you with your hair, right? You can style your hair different ways. It's a way of manipulating it. And in a BGP world, the reason we want to do that is, even though you'll hear us talk many times about that BGP is a routing protocol, we know that BGP runs on TCP. We know that it runs on port 179. So we know for a fact that it's also an application, and predominantly an application that was created for the idea of having flexibility in what we call traffic engineering. But in simple terms, basically just means I can change, I can adjust, I can manipulate my various characteristics for a specific outcome. Generally speaking, in BGP land, that means some type of policy that is going to be tied back to a business use case on something that I want to accomplish. Very simple example is, and we'll get into a little bit later on how we can manipulate these attributes or these characteristics of what makes up a route, is if I have two connections, it doesn't matter if these are to the same service provider upstream or if it's two different ones. But let's say one of my connections costs me a lot of money to uphold. Let's say you can even say it's an MPLS connection. And then the other one is just a simple internet-based connection, like a what we call front-door VRF, which is basically just a specific, unique, cutout logical routing table that gets me to the internet with the actual ISP. What I can do in BGP, I can say, okay, if I send traffic through my MPLS network, it's going to cost me X amount of dollars. And it's going to cost me X amount of dollars more than if I send it directly through the internet. So a business decision could be made to say that we want to predominantly, for all kinds of traffic that does not require some type of quality of service, right? Some type of guarantee of how the traffic is managed when it gets there, any type of performance guarantees. Just if it doesn't require it, I'm going to send it out there because I pay less for it. That is a business decision as to why I would want to do that. And then on the flip side, if I have any type of critical data, let's say I have a connection back to my data center through an MPLS, perhaps I'm using my MPLS also for voice over IP traffic, which is going to be sensitive to performance gains. And as well as, let's say you have some type of video, anything that can tie back to that needs required performance guarantees, we call them service level agreements. I want to use this particular MPLS connection. Now, from a business use case, it makes sense. I'm only going to send a minute amount of my traffic one way. So that's an acceptable cost. Anything else, I send it out my cheaper connection. That's also an acceptable cost. I can't really do that very easily with something like OSPF, ERGRP. And good gosh, if you're still using RIP, you definitely can't do it with RIP. But with BGP, because we have so many of these things that we can manipulate, it allows us to implement and actually design our network based on business policies that we want to enforce. And as you know, as an architect, having this type of flexibility to be able to do that type of manipulation is going to be critical in being able to just bring a use case to life. And that's what eventually your employer wants from you, to be able to have something in your arsenal, a tool set. That's what BGP is going to be, to bring about these type of policies. So I hope that answers your question. And we'll get in a bit more detail also on what are some of these attributes. We'll go into the sequence on how these attributes are preferred from lowest to highest and so forth. So there's plenty more to come. Oh, Ayana, there you go. Thank you for that in the chat.
Absolutely. So we're going to actually have some fun, and we're going to get to certain parts of this. So give me a hashtag BGP so I know you're awake, alert, and oriented. And then we'll get into that. And we're going to do some fun traffic engineering with those BGP attributes. And you'll see exactly how they come into play. So I'm going to talk about a concept called a finite state machine. And BGP operates using a finite state machine. So what does this really mean at the end of the day? It means that BGP has a bunch of pre-programmed states. And it also means that depending upon what happens, we'll get to the net result. So in a normal world, initially the two systems connect, an open message is sent, the router transitions to open send, it goes to open confirm, and then it gets established and they start exchanging routes. This is what we want. But as soon as the connection goes, if something wrong goes, it transitions to active, and if it gets fixed along the way, it'll go to open send. But if not, it goes back to idle, the starting point. Or if it reaches open sent, but messages are, but if it reaches, if an open message is sent, but it's not received or replied to, then again, it'll transition to active. So that's going to be the machine that we're actually talking about. And now we're going to get into what actually goes on in these individual states. So we have the states of idle, connect, active, open sent, open confirmed, and established. So let's talk about what's going on here. Idle, kind of like your car. If it's sitting in your driveway, it's idle before you put it into gear and go. So when you have BGP, it starts in the idle state. And this is basically where the routers are waiting to establish that TCP connection between them. Now, if there was a misconfiguration here, like for example, you put in the BGP neighbor's wrong IP address and you don't establish a session, it's going to stay in idle. Now, assuming the TCP connection works, the TCP connection between the two routers is good. Now what happens is the router will actually send an open message to the neighbor. And as soon as the open message is sent, the router is going to say, I did my job, and it's going to transition to something called open confirm, which is the next state along the way. So TCP connection is established, BGP information is correct, and an open message is sent. Poof, you're in open confirm. And this is perfect. This is what we want to actually occur. Now, if for some reason this connection is unsuccessful, the TCP connection is unsuccessful, BGP will continue to listen for a period of time for a connection. And what will happen is, if it doesn't find anything, when it transitions, it'll go to the state called active. And active is not a place where you want to be. Now, active, if it's still broken, will transition back to idle, and then you got to start this whole thing over again. Now, if you got it misconfigured, it's going to be a cycle of idle, active, idle, active, idle, active, idle, active, and you don't want to see this. Many of us have seen a lot of this going on earlier in our careers, and then we had to debug the information to figure out why. So, if the connect timer were to expire, for example, while in the connect state, guess what happens? And we don't establish a TCP connection, we've got another problem. So if anything happens outside of the normal, we're going to right back to idle. So idle, waiting for the TCP session. Connect, waiting, basically, the connection is established, and now the router basically sends an open message to its neighbors. This isn't the way it's supposed to work. Bear with me a second. I made my mouse so big because I couldn't see it with my 4 monitors. And after I made it so big, I found myself in a position that I couldn't see my screen, but that's neither here nor there. So that's what's supposed to happen. Now we get to this position called open sent. And in this state, the open message is sent. BGP is waiting to hear an open message from its neighbor. When an open message is received, if something is wrong along the way, a notification message will be sent and it'll transition back to idle. But if everything goes right and no errors occur, the routers both come up, they establish their TCP connections, which is what you want. They send their open messages, and then they go to open sent. So far, so good. Now, as soon as we transition to open sent, the routers send a keep alive to each other, a health check. I'm here, how you doing? I'm here, how you doing? Now, the next thing that we'll get to, assuming that occurs, is we reach the state of open confirm. And that's why we're waiting for that BGP keep alive to be reseen. And if we get that BGP keep alive from the other neighbor, now we transition to establish, and that's when we start sending our information to each other. But if a notification is sent, because remember, notifications mean something bad, now we go back to idle. Are you sensing a theme here? What we really, really, really want to do we want to go from idle, we want to go to connect, we want to go to open sent, we want to go to open confirm, we want that keep alive, and then we want to establish that session. Now, if anything goes wrong along the way, we either transition back to active, and if it doesn't get fixed, we go back to idle, or we go straight back to idle, depending upon what it is and the kind of message that's sent along the way. Notification message, something wrong, go back to idle. Gonna say it again. If everything goes well, we go from connect, we go to open consent, we go to open confirm, keep alive is sent, and then we get to establish, which is the party time. But if anything early in the process goes wrong, for the most part, we go back to active. If anything, and if that gets fixed, we'll transition to a better state. If it doesn't get fixed, we go back to idle. And if anything's really wrong, we go back to idle. So If you've got a router, you're not seeing the BGP routes on it, and you're transitioning and you see active or idle, there's a good reason you haven't fully established your TCP BGP session. Okay, now the nerd knobs. The BGP attributes are the nerd knobs. Great question was asked about these nerd knobs. Now we're going to talk about them. So BGP messages give you information about the route. And for example, we can actually, if I were to set a community red, I could tell another router, hey, if you see the red community, don't export those routes, which means that provider wouldn't become a transit autonomous system for red's routes. I can do any kind of weird, wacky things I want based upon these attributes. So the attributes are messages about the route. And we're going to use these attributes to influence traffic. And we're going to cover the BGP path attributes in this section. So the first one is the origin attribute. This is how the router learned the route. What do I mean by this? Well, we could learn the route from our interior gateway protocol. And if I'm on a router and I learned it from my interior gateway protocol, that's the most reliable information. If I learned a route and I learned it from an external provider, like through BGP or an EGP learned route, that's going to be the second preferred route. Now, we also have this concept of a route attribute called incomplete, which is I don't know how I learned the route. I want you to think about this. Mark is my interior gateway protocol, and he tells me the route. That's probably the most reliable. Some external provider tells me the route via BGP, but they're not under our domain. They're not under our control. That's why it's the second preferred route. If I don't know how I got the route in the first place, that's like when someone says, I heard this, and I say, who was the source of information? What were the credentials? What are they known for? It's the same kind of thing here. So that's why incomplete is valuable. If somebody says, everybody should get surgery, would you believe that person? Well, you might say, oh, what is their position? If they're the Surgeon General, you might be saying, okay, it's got some credibility here, but okay, what's wrong with it still? Because it doesn't make sense. But the better the source of the information, the more likely you are to act on it. BGP is the same. Now, the next attribute we're going to talk about is the AS path. And the AS path is an interesting attribute. And I'm going to show you what it looks like along the way. And I'll show you why this matters and how we use this information. So let's say this is ISP-A, and this is ISP-B, and this is ISP-C. And we had, bear with me. I said C, but I didn't change the letter. So let's say we have two paths from ISP-A to ISP-B, ISP-B to ISP-C, or Internet Service Provider A to Internet Service Provider B. So what happens, what this router is going to get, it's going to get these path attributes, and it's going to say, on this link to get to ISP-C, what you have is ISP-C in the path, but it'll be their actual autonomous system number. Now, in this case, if we look at the top path, these path attributes will show us that in order to get to ISP-C, we have to go through ISP-B, comma, ISP-C. So if you look at this, which looks like the shorter path? One internet service provider or two internet service providers? So generally speaking, all things being equal, meaning not preferred by another route, the shortest AS path wins, if we're leaving it up to that attribute. Because this one autonomous system looks better than having to cross two autonomous systems. Now, the next thing is the next top attribute. You want to tell me one CCIE that didn't get frustrated over this next top attribute, that they spent hundreds of hours not understanding why a route wouldn't be in the routing table, even though they should be? is for this particular reason, the next hop was not reachable. So BGP's next hop attribute states that the next hop has to be available in order to send traffic to it. Okay, well, think about it. I send traffic to Mark, but he's not available. That's no good. So it's just wasting all my internet bandwidth and all my links. So we have to think about this. And this is important. The next hop attribute is, what is the next hop IP address? And is it reachable or not? And what's going to be the time to live of that message? How many hops can I go along? Is it just one hop or is it more? And if so, we need to address that. Now, this one is a weird one. It's called wait. Wait was originally Cisco proprietary, but it's now on AWS's BGP implementation and a few other ones. So wait is a feature that can influence your egress or your outbound traffic. It is local to the router itself, meaning we're not going to be sending this. And basically what it says is, if all paths are equal, prefer the path with the largest weight. And we prefer the path with the largest weight. And I'll show you what I mean by all things being equal, because certain things matter more than others. So there are main attributes. And there's obviously a couple others, but these are the main that we typically care about. So let's talk about how BGP makes a decision. And this is why I was talking about that all things being equal. BGP routers generally prefer the path with the highest weight, especially Cisco, as well as that you would deal with, as well as AWS, for example. Now, if the weights are equal, then talk about the local preference, which is another attribute on that router. Generally speaking, routers prefer the path with the higher local preference, or the highest local preference. Now, I can learn the route on my device itself or my router, or I may learn the device on another's router. Whisper down the lane is the least effective form of communication. So if I learn it on my own device, it's typically going to be more reliable than if I learned it in another way. So prefer the path with the highest weight. Prefer the path with the highest local preference. Prefer the path that was originated by us because we're most reliable to us. Now we'll get to prefer the route with the shortest AS path. And if the AS paths are the same, now we're looking for the route with the lowest origin code. Remember, origin code was where the interior gateway protocol was preferred over an exterior gateway protocol over we don't know how we learned the protocol. Bear with me a second.
And I might as well add just here, Mike, while you're doing your thing, is for everybody, it's going to sound like it's a lot of information that's coming your way, and that is true. A lot of information is coming your way. But when it comes, for example, to the learning the attributes and then the actual order in which these attributes are considered when making a decision in regards to what the best path actually is towards a destination. So you got to remember this. For testing purposes, if you take any type of networking exam, you're probably going to be tested on if you understand what that sequence is. In real life, though, just understand, if you're going to be designing and then adding the architecture piece on it, that's that business piece, you generally are not going to be expected to be like a network engineer and just rattle off all the different attributes that there are and then in their order. And one of the reasons for this is that each attribute can be used for a specific purpose. And then depending on what type of vendor platform you have, if it's going to be Cisco, if it's going to be Juniper, they're going to have slight variations in some of the order in which the attributes are being considered. Like, for example, what Mike is discussing, he's not going to discuss with you accumulated IGP metrics. But for example, if you look at Juniper's documentation, they'll have this, I think, like as the second or the third actual option that you're going to have to look at. So just to keep that in mind, as an architect, you will have your actual documents that you can reference and then make a decision on exactly what you will use. But for our discussion, it's important just to get a feel for these attributes, what they are, and why are we considering them in the specific order. And I want you to keep in the back of the head is these are my ways of making changes and manipulation, and the order will matter because depending on which characteristic or attribute I manipulate, that is in the order that also going to be considered. And perhaps at that point, then I can make one route preferred over another, even though perhaps they have different attributes to them that I'm going to be manipulating. So just something to keep in mind.
Sounds good. Thanks for that, Mark. I was trying to build myself a slide that I could actually share because I'd had attributes and a whole lot of other things because I want to be able to share this in a minute. So thanks for that in the meantime. So we already talked about the top 5. Choose the route with the highest weight. If the weights are not set, we take the route with the highest local preference, then where the route was originated, then the shortest AS path, and then the lowest origin code. Okay, so now if the origin codes would be the same, what would we go to next? What we would go to next is something called the MED, or the multi-exit discriminator, which typically prefers that we would go to next, prefer the path with the lowest MED. And now if the routes are still equal, now we prefer the path with the shortest path to the BGP next hop IP address. And if the routes are still equal, then we take the path that we received first. And if the routes are still equal, then we prefer the route, the path that comes from the route that was advertised with the lowest IP address. So we start getting ourselves into wacky things, but each one of these gives us the opportunity to tune things. So I'll show you what I mean by here. This is what I was trying to help create, trying to pull some things together. So we prefer the path with the highest weight. So what does that mean? If one path has a weight of 32,000 and the other path has a path of 35,000, we take the 35,000. Now, if the weight isn't set or the weights are default, meaning identical, 327658 or something like that on both routers, then the next thing we're going to look for is the highest local preference. So if one path is 100 and the other path is 200, we take the 200. Now, next we prefer the paths that were originated on the local router. Again, this makes sense to us. Why are these things high up? Because they're normal, they're tunable, we can figure out where things are originated. AS path, again, very good logic, at least where it's coming from. The logic here is, here's my path, here's my path, here's my path. Going through 2 ISPs is probably cheaper time-wise than it is going through 3 ISPs. It's not guaranteed, but it's an option. Then it's the origin code, meaning what's the best option that we talked about? IGP, EGP, or I don't know how I got it. Then, if all that's the same, then we choose the path with the lowest multi-exit discriminator. And then, if we have the ability to learn via BGP, either eBGP over iBGP, generally speaking, it prefers the BGP route. Now, some routers like Cisco have different administrative distances or believability of these routes as well, iBGP versus eBGP and others, but keep that in the back of your mind. Now, this is where it starts getting cuckoo, which is if you don't actually set anything that you want, now these devices are going to have an election and they're going to determine who has the lowest IGP metric, which still makes sense because it's the lowest path to leave your system. Now let's choose the oldest route. Why? It's been around a long time, so it's probably really stable. Now, this is getting ridiculous. Choose the path with the neighbor with the lowest router ID, and you can set the router ID so you can know it. There's better ways to do it. And now choose the path through a neighbor with the lowest IP address. This is silly business, but something has to happen along the way. But I don't want to leave my BGP decisions and paths to whatever's the lowest IP address. So I want to plan it out. So that's really what we're talking about with this BGP path selection. So now that you know this, I'm going to walk through a couple of samples with you, sample scenarios with you. And after that, we'll do some little questions and answers to see if you're all getting it.
Did you want to take a couple of questions, Mike, before we?
Yeah, let's see if there's any. Let's do that. Let's see if there's any questions.
All right, let's do that.
The traffic engineering is the fun, exciting part.
That's where the policies come into place. All right, let's take a look and see what questions we have here. From HG, Mike and or Mark, can network administrators set a threshold for the number of prefixes received before a warning message is generated? HG, the way that actually would work is that you would use a feature where you would set the maximum amount of prefixes that you're willing to accept, and that's going to then be associated with a threshold that you'll configure. Here's the thing though, by default, when you're using this, I think it's called maximum prefix type of feature. It's a little bit different in every vendor, but if you're using that feature, the default behavior is that when the actual threshold is exceeded, that the BGP session or the peering session is actually terminated, meaning you'll actually get the notification message, and then you're going to get the TCP reset, and it's going to bring you back to the idle state. So that's the default behavior that's actually going to happen. What you can do, though, is you can set it to receive a warning that you have exceeded your threshold, but it's not going to tear down your session. So you'll have to actually have a particular use case why you would actually tear the session down compared to another one. One that I can, for example, think of is, let's say that you don't want to receive the full routing table or even just a partial view of the global routing table. But now there's somebody who's trying to perform a denial of service attack on you by nuking either your CPU so that it can go through a best path selection algorithm, or eventually just kind of max out your memory as you're trying to install these things. And then, of course, if you don't have enough room on your actual line card, which is actually going to be your memory on where you can place these, then that's also going to eventually cause a availability issue on your router. So from a perspective of not being part of the denial of service attack, you might want to set that threshold higher. And you can also use this as part of an overall strategy on how you can validate your route origin and also kind of prevent route hijacking. So it's kind of like a multi-step where you can use these things. But remember, by default, I'm going to tear the session down if I exceed. If I don't want to do that, so that's where you have a little bit reverse, then I want the message to be generated that, hey, there's an issue with it, and I need to have the warning. You might actually take that and log this into, let's say, if you have some type of, you can use a SIEM system, like a security information event management system, actually also same for networking. We'll just call these extended detection and response systems, like something like a Splunk. You can kind of get your syslog kind of thrown in there, and then you can also have a generated message that comes to email or whichever way your organization has it. But you would choose and try to pick one of them that is applicable based on a business use case. All right, let's take a look at our next question. So from Raja, if weight is a Cisco proprietary attribute, how do we know along our path that other routers will honor this attribute? It might disappear midway. No, you will not know. And that's a problem with the weight attribute. As a matter of fact, the weight attribute can be so problematic that it's device specific, or we can even say process specific to the router. And the problem there is, even within your own routing domain, this autonomous system, this attribute does not get propagated to other routers through a BGP update message. So that's one of the issues. So what will basically happen is the other routers will never know that you have that attribute configured or manipulated or do some type of manipulation. They'll never know because you'll never tell them about it. So that's why, generally speaking, what you want to do is you want to use things that are going to be recognized and then honored by other systems. So instead of maybe, let's say, weight, local preference might be a better solution. But again, there's specific use cases for everything. And you want to make sure that you align which attributes you use based on a particular policy and an outcome of the policy that you're trying to achieve. Mike?
Yeah, and a little more about that. Weight is kind of local to the router. So it's only designed to influence our local router versus other routers' paths along the way, like these other attributes. Local preference is also local to the router. So the key is, if let's say I was getting routes from someone and I wanted to use weight, I could have them send me a community, a very specific community. And like say, so Raja, you send me a message and it's got the Raja community. Now I can choose to create a policy on my router that says, see the Raja community in BGP. change the weight on this router that I want it to be. So I can do it that way. But generally speaking, weight is local to the router. So if AWS is doing it on their one router where you're connecting to it and you're doing it to AWS, that's just across that link. It's not something you're going to be pushing across your IBGP peering systems and you want to be pushing into other autonomous systems. So it's local to you. So generally, I would only use weight on the outbound routers that I would actually be dealing with to manipulate outbound traffic. But if I wanted to, I might set the weight on both sides for different things, which I could do if I own both sides. Or what I could do is I could agree with a policy with my internet service provider. I want you to manipulate based on whatever this. I prefer you choose the weight. So I want you to implement this weight. I will be implementing this weight on these links. You could do that too. But remember, it's not going to be propagated. But whenever possible, just use something open. Just use something that works with all routers in the first place.
Yeah, I mean, if you have the choice, unless you don't need to go through your internal systems, meaning let's say you run internal BGP, meaning it can actually understand these attributes, you'll use local preference because that actually gets added to the route basically through the update message. But if you don't need to do that, meaning the other routers in your domain don't need to know about it, then weight is perfectly fine. But you do want to be aware of if there's ever any trouble. And I know we don't usually discuss a lot of the troubleshooting and the engineering aspects, especially since we're trying to focus on architects. But part of the architect's job is to make sure that the system that you design not only meets a business requirement, but also that this system can be supported. So you want to be able to design an actual BGP system so that the engineers can troubleshoot it. You don't want to cause more issues for them to be able to troubleshoot the system because there is no proper explanation in regards to why and how you designed the system. And that's where weight can get a little bit problematic. But for simple things like that, it's a very quick, easy fix. If you have good documentation skills, just throw it in the documentation that on this router, it could be based on the peering session. I know we're not going to go into those details, but you can also do per prefix. That might be worthwhile. But I'll leave it at that. We're going to go down a rabbit hole and we start talking about all these type of manipulations. But just keep in mind what your outcome is going to be there. All right. From John Doe, what happens if there's no destination address and how to prevent this situation? John Doe, if there's no destination address, I will never know about it because there's nothing to advertise it. But let's reframe this question just a little bit. What happens if there's no next hop or no valid next hop? What will happen there is in the BGP database or the BGP routing table. So basically, this is where BGP will do its full kind of analysis of the different routes that get injected. It will run the best path selection algorithm to select which route is the very best before it puts it into your routing table. If there's no valid next hop, the route will actually be designated as inaccessible and it will not be considered as a possibility in the calculation of a best path selection. So the next hop is actually, having a valid next hop is the first step actually in the best path selection algorithm. Many times it's not listed because they figured if you're going to do the actual algorithm, the actual best path selection algorithm calculation, that you do have a valid next hop. But if you don't have it, the route is not being considered. It gets tagged as inaccessible. Now, if you have a case, and I'm going to add some additional notes later in the chat about this. But let's say somebody is trying to advertise to you a prefix or like a network address that is not valid, then that's going to be part of a route validation origin mechanism. So this is going to include things such as the public key infrastructure. It's going to include digital certificates for authentication and validation purposes. You're also going to have private and public encryption keys that are also going to be necessary. And what you'll need to do is, and we're not going to go into many details, but what basically will happen is that as long as the different organizations that own autonomous system have actually provided the routes that they're going to be advertising, you can dig into a public database that you can use as a validation mechanism to make sure that the routes that you're receiving are, first of all, valid routes and that they originate from the appropriate autonomous system. This is generally something that service providers will use. since as customers, we are, most of the time, we're sitting behind them. So the service provider is going to make sure that they only advertise to us what we requested. And on the other end, they also request that we only advertise our owned private space in that case. So two different things, but I hope that gives you a little bit of an idea of what can happen there. But when it comes to route validation, AS path validation, that's going to be way too far out of the scope of it. But I will provide you in the chat a couple additional references that if you want to get really geeky, you're welcome to go ahead and read. All right, let's go ahead and, you okay taking a couple more questions, Mike?
Yeah, why not?
All right. So from Cloudy, who decides or who owns and manages autonomous system numbers? And who decides the block of IP they should manage? So somebody in the chat was so kind to let me know it was IANA. That is the regional or the global entity that actually manages the autonomous system numbers. You will have to go through a registration process if you want to own a public autonomous system number, meaning one that is going to be publicly recognized, and it also has to be, of course, unique. You can't have the same one. Now, you will generally own the autonomous system. You will also manage it, and you will be responsible for it. But it will be registered with ANA, of course, that is part of you. If you look a little bit back in the chat too, let me see if I can find this for you, Cloudy. Go ahead, Mike.
While you find that, I'm gonna mention that ARN is also a place where you could buy your autonomous system numbers. The American Registry for what do they call it, Internet numbers, and that's where I've always gotten my numbers from.
Yeah, there's various regional internet registries that you can get the autonomous system numbers for, and also the IP addresses. Now, the IP addresses, just so you know, this is again going to depend on if you want to purchase them, meaning that you own them. We call them the provider independent space, or if you're going to have provider aggregatable space. Basically means you're not independent. This is basically what we all do. We go to a service provider and they'll basically rent us the IP addresses. They own them. They are registered with their regional internet registries that they are actually owners of them. But just so you understand, the IP addresses and the autonomous system numbers are two completely separate concepts and are used for different purposes. One is just used if you want to have actual global access to the internet. And then the other one is used for specifically BGP purposes to identify your administrative, we call it administrative domain, basically the domain or the organization that you own and that you have control over. That's what an autonomous system number is. That's why in my mind, the way I associate it with, I would view, like say I'm in the United States, I would view United States, that name, as one big autonomous system. And then what I can do is I can have other autonomous system, maybe for particular states or so forth. But if you want to get to any of them through any of the ports I have, you need to know what is my actual autonomous system number so that you can address it to me. And Mike already got into it a little bit in detail. Autonomous system numbers are also used in the way of selecting how my traffic is actually going to go through the internet. And it's also one of the ways that we prevent routing loops when it comes to BGP. And in one of the videos, if you've not, there's going to be a link in the chat in the description. Go download the actual networking videos on BGP. We include a little bit bonus in regards to internal BGP there. And I give a little bit of an explanation as to why iBGP can become complicated because of what happens to the autonomous system numbers and this loop prevention mechanism that's going to be manipulated, not necessarily in a good way. So we'll have to know those rules. But I've included, I think about, I know it's over 40 minutes just talking about that, showing you a demonstration as regards to why it works this way. So go ahead and download them, take a look at them. I think you'll enjoy them. All right. Let's take a look at a couple more questions here. So from Cloudy, says, where do we get to see which block of IPs or block of IP each autonomous system manages in order for us to create the most efficient BGP route for our company? Do they advertise these IPs in a specific location, such as a website? Autonomous system numbers, if you look at the link that I sent you, you'll see there's going to be a link of all the autonomous system numbers. There's another link that IANA provides, which actually shows you who owns a particular address space. Once we get off the question and answer, I'm going to look for that and I'm going to provide it to you if somebody else hasn't done. But there isn't one, let's say, one page that you can go to. You can go to IANA, they have one page for the actual autonomous system numbers, and then they have another one that just talks about the address space, the IPv4 address space that is being rented. There are ways, and it was mentioned early in the chat, there is things such that we call BGP looking glass routers.
Yes.
And what this is if we're trying to take a look and see if our policies are going to take effect, let's just say that. Let's say I made some manipulation to one of my attributes. What I would have to do to see if these attributes actually took effect, I have to look at somebody else's perspective. So you have companies like Verizon, you got AT&T, you got Lumen/CenturyLink, GTT, NITA will do something, British Telecom, Telia, Italia is there. They all have their own looking glass. And what you can do is you can log in and you can take a look at their actual BGP routing table or their BGP database. And it's going to show you the actual prefix, which is going to be what you mentioned, your IP address space, and of course the autonomous system number that not only is associated with that prefix, but all the ones that eventually had to pass through just to get there. And that is one of the mechanisms that you can tell if your actual policy took effect. Mike?
Yeah, and the key to remember, how Claudia, is we can do all of this, but it's still not going to give us necessarily the best route. It's going to give us what's going to look like the best route. For example, it'll say this went through less AS hops, for example. But what it's not going to show us is the one that had longer AS hops, had links that were unsaturated and unused, and they were 800 gig links that were bundled together, where the one that looked better actually is a 100 gig link. You're not going to see that information from BGP. So what we can do is we can choose to be the best path. We can choose, and we're going to work through some examples on how we choose different things. But at the end of the day, that's why software-defined networking is one of the reasons if we have to actually determine the best path through an unknown network. But we could also be using BGP. We can be using other protocols to signal various tunnels that we might send through our IP connectivity as well. And when we're signaling this tunnel, we can guarantee bandwidth potentially at certain places along the way, not necessarily internet, but on the internet we could do it. So there's a lot of options we have and ways that we can actually do things. It's just the question is evolved is what are we trying to achieve? And for us, often it's just load sharing over the links we have, or for an internet service provider doing certain things, or choose the least expensive link if you need to, and or choose the lowest latency link if you need to. And we're going to walk through some of these situations in about a second.
Yeah, before we go on to the next question, I'm going to add a book name into the chat. And this is, Mike loves this book. Most people love it. They genuinely tell you if you're starting off anywhere with BGP, take a look at that book because it explains how the actual internet infrastructure works. And it gives you walkthroughs in regards to the different attributes and how they get applied. So I put in chat, it's called Internet Routing Architecture, 2nd edition by our late Sam Halabi. Fantastic resource. If you want to take a look, you can get it through Riley Books. You can get it through Amazon, and then many of the different, look at one of your local book retailers to see if you can find it. But it's a wonderful resource because it does touch on a lot of the stuff that Mike just said, and also gives you an idea of as to why certain things happen and how they can, without focusing so much on the configuration part, because the configuration, believe it or not, don't always tell the full story. So you're always looking for the outcomes. And this book does a fantastic way of telling you the story of the beginning, the middle, and then the end or the outcome of policies as they're being applied. All right. Does the frame size and MTU affect the weight? No, it does not. What happens is when you send any type of attributes, now in this case, the weight attribute does not get basically sent to any internal or external BGP peer. So in that case, it doesn't matter. But what happens is these actually get attached in the update message, and they get added as not capability, but I think options. So what happens basically is whatever your actual maximum transmission unit is basically the size that the interface can hold a packet size at. If that is, let's say, generally it's 1500 plus 18 bytes for TCP, so 1580. So we have that. Actually, I think it's 20, and then 18 is for the actual layer 2 header. So, but in any case, you have roughly, generally speaking, like 1,460, something like this, where you actually have a segment size in there. What happens if that exceeds, the BGP update message actually exceeds that size, it starts fragmenting the packets and it just sends a few additional update messages. From that perspective, you're not going to have an issue with the MTU frame size. Where the MTU could be an issue is really with OSPF, because it's a requirement for neighborship establishment. Because there, what OSPF does, it actually sizes the update packet, the link state update packet that's being sent. That's where that MTU or that maximum transition unit size actually will matter. So, and then of course, if you're going to data center and stuff like that, believe me, it doesn't matter anyway, because you have what we call jumbo frames, so 9,000 bytes and more. But for all intents and purposes, what you're asking, no, because of the way the attributes are actually being propagated and fragmented if necessary. Yeah. You had something to add before we go on to the next question?
No, I think on this question, I may actually answer some of it as we continue things. So I'll let you answer this, and then I may, depending upon, also want to include something like this along the way.
Okay. All right. So from Tunde, the question can be reframed that if the destination is valid, but the particular prefix within the summary route is not being used, what will happen to the route? So you always got to look at it this way. If a route is not used, it doesn't matter if this is a summary or an aggregated route, or if it's just a prefix specific route. If it's not selected as a best path based on whatever attributes you have manipulated. If you didn't manipulate anyway, of course, you're going to get to local preference. If local preference is not there, then eventually you're going to get to origin, and then you're going to have to figure out, is it locally originated? If not, so you go down the best path selection. But in either case, if it's not selected as a best path, it just gets stuck in the BGP table. That's where it gets stuck. And if something happened to the best path, let's say that path is withdrawn through a withdrawal message, then what happens is if you have any additional routes to the destination, then the best path selection algorithm is going to run on that, and then eventually it's going to get selected. But to basically say, if it's not a best path, it just doesn't get used. There's no harm or done. There's other issues, or I would say other, not issues, but minutia when it comes to aggregated routes, but they more deal with the way the autonomous system path is either kept intact, or it can cause issues with you potentially causing loops in the network for upstream, or if you're transient, it could be, lateral autonomous systems. But in either case, nothing really happens. It just sits in the BGP routing table.
He may have been answering one other side of the question, Mark, which I don't know, which is why I'm going to cover a little more. So let me show this along the way. Tyrone or Chris, if you want to make that a little bigger. So he might be saying this. What if you've got an aggregate route of the one, like say a 192.168.0.0/22? Oops. This is what happens when you type live. And let's say maybe one of these routes in particular is missing. So if you've got an aggregate address that's sending this 192.168.0.0/22, and a packet hits that router that's destined for 192.168.2.0/24, the router will drop the packet. Because if it doesn't have a route in a routing table, it's not what it's going to do. Now, where do people get themselves in trouble? Is the people that are designing the systems don't know the IP addresses and an IP addressing and route planning. And here's where stuff gets really icky. And let's say you've got a user that advertised this aggregate space over here. And I'll show you where it works and where it doesn't. And let's say this is your cloud provider. Doesn't matter where it is. And by comparison, let's say this is your data center, wherever you're at. If somebody accidentally did this with their IP addressing, 192, oops, because you'll see it all the time, 192.168.2.0/24. What they ultimately did is they set themselves up for this concept of discontiguous IP addresses. where here you've got this cloud provider saying, hey, I can reach 192.168.0.0/22. Unfortunately, this is contained in here. Now, to the routers that are going to be local to this area, they're going to have a more specific route than the aggregate route in their interior gateway protocol, so it's not going to be a problem here. But if we had normal environments where this person starts advertising certain routes and this person starts advertising certain routes, at some point on the internet, we're going to run into trouble and we're going to cause some confusion potentially. So IP address planning is going to be the most critical thing we can do to make sure our IP addresses are laid out and we're going. So why don't we do this? Let's get back to some of the BGP traffic engineering that we talked about, things that we actually need to do.
Question, Mike?
I think we should take the questions after we do some traffic engineering.
Okay.
Because I think they're going to keep coming in, and I'm thrilled about that. And I love that. So let's talk about some BGP traffic engineering, and then let's take questions that are inclusive of everything. So let's talk about some basic premises of routing and some basic premises of internet routing. And here's where things get hairy and things break. A few minutes ago, while Mark was speaking, I drew up this thing that I wanted to share with you. So let's say this is our data center, and let's say this is our cloud provider, AWS, Azure, Google, who cares? Doesn't matter. And these are obviously our routers on both sides. Now, in a perfect high availability setup, we're going to be using multiple routers versus a single router, but I want to make it real easy here. So we don't have to run IBGP between the two routers that are going to be connecting to the two internet service providers. We want to make this simple. So imagine an environment where, let's just say, and I'm picking ISPs out of a hat. Let's say that your AT&T link, for argument's sake, or CenturyLink, or NTT, or Verizon, it doesn't matter. But let's just say this link is 4 milliseconds. It's a higher latency link from service provider A. And let's say that your next link is 2 milliseconds. Now, the problem is the way the routers are going to work by default. Half of the traffic is going to go out this link if we do nothing about it. And then if we have multipath set up, and the other half of the traffic will go out this link. So far, so good, right? 50% of the traffic goes here. 50% of the traffic goes here. All good. Here's the problem. When it comes to returning from the cloud provider, some of the traffic is going to take this link at random, and some of the traffic is going to take this link at random. But now we have to understand that because these links are different speed, we're going to be getting messages back that took the bottom link before we got messages from the top link, even if they were sent first. So it's like having two people in a room that you're talking to, and their messages are being played at odd times. So you don't even know what messages you're getting from where. This is asymmetric routing, and this is something that can be scary for real-time applications like voice or video or anything. So it's not going to be necessarily so good for TCP connections or UDP connections either. So what do we have to do? There's a couple options that we have. Now, if you took what's, I consider it silly, but in the AWS Advanced Networking, they've got a real good example on how to deal with the situations. Block one of the links. And that's literally what they teach in an AWS Advanced Networking. Block one link, and then you don't have this problem. See, here's the problem. You're buying two links. You're paying for two links and just saying, I'm just not going to use one? I don't like paying for stuff I don't use. And no business does. So businesses want to load share across their links. So that means we have to find a careful way to do this. So let's say that my cloud provider itself, and I'm going to walk through various scenarios for you, which is going to show routing. What if we decided on BGP on the top link to advertise 172.1? What did I do here? 172.16.0.0/16. And let's say on the bottom link, we advertised 172.17.0.0/16. Now, in this particular situation, the routers are going to prefer the path with the most specific route, right? That's how routers operate. So right now, as it stands, all traffic for 172.16 will be coming out this link, the 4 millisecond link, And guess what? It's going to come back on the 4 millisecond link. They were great, right? Now the traffic on the bottom is that for 172.1.7 is going to take the bottom link. And guess what? Its return traffic is going to come back. Okay. So far, does anybody see any problem here? I want you to tell me what problem I have in the chat box if you see it. I want to know that you're awake. What's the problem going to be? What happens? What's the problem going to be? Let me know if you see the challenge. And if not, in about 45 seconds, I'm going to go over the challenge. So let's have some Jeopardy. Think Jeopardy. What is the potential risk here? What is the challenge here? What is the concern here? Do, 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 do. I don't know, I'm not a musician, but that's what Jeopardy music used to sound like. Anybody see the problem? Because there is. There definitely is. Routers do prefer the path with its most significant, so we've got great traffic and load sharing right now, but we do have an architectural problem here. I don't know what you mean by the slash CIDR. You may be onto something very big. But I don't know what you mean by that. But you could potentially be onto something. Okay, well, I'm going to make it clear. What happens if this link goes away? It's gone. Does the 172.17 traffic traverse the link anymore? No, we've got nothing. So we lose a link here, and we're all happy. And we still have our 172.116 traffic, but we lost the bottom link. So what's our alternative? Routers prefer the most specific path. So what we could do, and that might be what the person was referring to, is on the top link, we advertise a 172.16.0.0/16, and then we advertise the 172.16.0.0/15. And why are we doing this? Well, 172.16.0.0/15 includes the 172.16 subnet and the 172.17 subnet, both /16. So we're good to go. And that might have been what you were referring to. Now we'll do the same thing on the bottom. We'll add the preferred path, and then we'll add the aggregate path. So in a normal situation, all the traffic destined for 172.16 always takes the top link. All the traffic destined for 172.17 takes the bottom link. And if this link goes away, poof, poof, the 172.17 traffic can still be seen on both sides because of that aggregate route. I hope everybody sees that so far. And by the way, this is going to be the easiest way of traffic engineering. Just send a more specific link on one side with a backup route, because a router will prefer a route in the routing table with a longer prefix, 10.0.0.1/30, over a 10.0.0.1/24. So that's going to be our first option. Now, there are other ways we could load share. So in this particular situation, I'm going to drop in a slide that we created earlier. And I want you to tell me in the chat box which path is going to be chosen for what. So in this particular path, I added, we've got our data center connecting to an organization's virtual private cloud. What is that BGP algorithm again? How does BGP select a path? Let's go back to that path selection process. So one of the things that we have is choose the route with the highest weight. Then we go, if the weight's not set, choose the route with the highest local preference. So in this particular environment, which is going to be the preferred path for 172.17.0.0/16? Tell me in the chat box. Is it going to be the top link or the bottom link? Let's see what you come up with. You can do it. prefer the path with the highest weight. Let me know. All right. Well, good, Renato. For 172.16.0.0, we're going to take the top link. Why are we going to take the top link? Because this path has the higher weight. So what is the implications of this? The implications is on the bottom, we're going to choose the 172.17.0.0/16. And it's going to be our preferred because it has the highest weight. Now, top link goes away. These are my only two paths. I'm going to be reaching everything on the bottom link. Now I've got load sharing and I've got no out of order packets. So this is a scenario we will typically use. It's one of the easiest ways to manipulate traffic when you've got a simple environment like going to the cloud provider, where you're just going back and forth with the cloud provider. Now, if the weights are equal, meaning 32768 is the standard weight and we haven't manipulated it, and if, at least on Cisco devices, and if the weights are equal, then we prefer the path with the highest local preference. So in this particular scenario, let's go look at what we have. We now, in this case, on the top link, we have a local preference of 200 for the 172.16.0.0/16 route. We also have a 172.17.0.0/16 with a default local preference of 100. On the bottom link, we increased the local preference for 172.17.0.0/16. The default is 100, and we raised it 200. And we added the route from the top link, the 172.16.0.0/16, with a local preference of 100, so it will not be preferred. So under normal circumstances, what's going to occur here? 172.16.0.0/16 is going to take the top link. 172.17 is going to take the bottom link. If the other link crashes, for example, everything will just go to the top link. So in either case, we have a way in and we have a way out with our traffic. Does everybody see that? Okay, so prefer the path with the highest weight, prefer the path with the lowest local preference. Now, what else could we do? You know, when you start looking at these looking glasses, you get to see who transports through whom, right? If we're going to use that information. So we got another way we could do it. Don't worry. We got another nerd knob, another geeky tool we can use. And these knobs give us so many opportunities. So, for example, here's another situation which you could do. And then I'm going to give you some problems, make you solve them. Ask you what I need to do. So in this particular case, look what we did. We learned 172.16.0.0/16. We learned this subnet on this link. Great. We also, and this is its normal path. That's its AS path, 64523. We also learned the 172.17.0.0/16 on the bottom path. And you can see that's 64523, the same autonomous system number we'd be getting here. So getting here. But look what we did here. Because we wanted the 172.16.0.0/16 to take the top link, but we didn't want to use, unless it was our last resort, the 172.17.0.0 on the top link. What we did is we prepended, or we added the same autonomous system number extra times. So if I added 2 of these, it's longer path than just the top one. If I added 3 of these, it would be a longer path than just the top one. So we can actually increase the number of ASs by introducing synthetic ASs by prepending or adding autonomous system numbers to the messages that we're receiving. So I hope you can see that. Bottom link, 172.17 preferred, because this path is shorter than these paths. Note they're two different autonomous systems. Actually, it's the same one. We just put it there twice. That's called AS path prepending. Remember, if all things being equal, we prefer the path with the lowest med or multi-exit discriminator. Remember that? So, if we're dealing with AS path prepending, guess what? That isn't, we talked about that, but we could also tune the med. So look in this particular scenario, which we drew up, and then we'll have a little questions test for you all now that I've walked through these scenarios and examples. In this particular case, look what we've done here. We've taken the route that we want to send on the top link, and we reduced its multi-exit discriminator metric. Likewise, what the 172.17 we used on the bottom, we reduced its multi-exit discriminator, which means that this will always be chosen, assuming both links are up for the bottom link. This will always be chosen over the top link. One of the links goes away, and everything will transition to the bottom link, and we're still good to go. So these are what we're really talking about as we're building these things. We're in an environment, we can change the weight, we can change the local preference, we can change the AS path. We've got a lot of cool little things that we can do to exchange to make our traffic go where we want to, and we would not have that. So let me give you, I'm going to draw up a scenario, and I'm going to ask you what I could do to prioritize one link over another while still having a backup channel. So let's say I'm going to draw this out. Now I've got an environment. Let's say this is my OpenStack cloud locally in my data center. Could be a Nutanix cloud. That's another great cloud as well. And this could be our cloud provider. Could just as easily be an internet service provider. But we said we were doing BGP for cloud architects versus BGP for network architects, but it's the same BGP. And in this particular case, let's say we had a router with two links. And let's say we have these two subnets over here. 10.0. Or 10.10.0.0.0 /16 10.1.0.0/16. These are what I have, and I only want to deal with, well, actually, no, let me add both sides of this. Yeah, I don't want to do that. Let's do Now, with this example, I want you to do some thinking, and you may need to do some route aggregation if that's the path you choose to use. So if I wanted to get 10. Let's just do it in one direction, in this way. If I wanted the top link to be used for, and we obviously in real BGP have to do it both sides, but if I wanted the top link to be used for 10.0.0.0/16, and if I wanted the bottom link to be, find where I put this. And I want the bottom link to be used for 10.1, and I don't want any out of order packets. Can somebody tell me one option that I have to make this happen? Tell me, and I don't care if you all have different options. Tell me what I could do, because you got lots of nerd knobs you can work with. What could I do to make sure that the 10.0.0.0/16 takes the top link, and the 10.1.0.0/16 takes the bottom link, And if I have an outage or one of the links goes away, I can stay up and still send my traffic. Put down the answer in the chat box. Give me something that I could change. If we were good today, you guys would be able to fill in this answer. So work with me. Help my ego, because we really want you to get this, me and Mark. All right. Shy crew today. Mark, you want to walk through some of the options you could use?
Well, I'm gonna go with the easiest one I can find. That's wait. But I would do it on both sides. Now, if I can't do both sides, then I have the option of local preference. I would actually make sure that on one side that I would say that this particular link is going to be ingested for that particular prefix. So I'm going to be a little bit more granular due to policy. If I had multiple links, that'd be a little bit different because there's additional things I can play with. But from that perspective, wait, local preference. And guess what else I could do possibly? Now, I'm not a huge fan of it, but there's other reasons why I'm not a huge fan of this particular attribute. But we did discuss the multi-exit discriminator. So that is also an option we can use. But there's a couple of reasons why perhaps I would rather go with wait or local preference. And that is number one, wait and local preference are all the way high up on the best path selection algorithm, meaning that they're going to be preferred compared to my med. But the med is also a little bit, can we call it particular in regards to when and how it will actually be comparing the med? So from that perspective, choose wisely when you're going to use it. But I would go with the wait and then the local preference to do the actual load balancing across. And you can always go, if you really wanted to, and I'm not going to be that great at doing the math in my head, but you can also go always with an aggregated route. So that you would have a shorter prefix on one of the links. And then as Mike discussed earlier, we have, generally speaking, routers prefer the longest match prefix, meaning what is my longest prefix to the destination? Because in the router's mind, the more bits I have in common, that means the closer I am to that network. So by using an aggregated route or a summary route, we can also do longest match prefixing. Just a few options. But go with wait and local preference if you can.
Yeah. And that's the key. We can use any of these little attributes, any of this little nerd nubs, as they used to call them. And that's the key to remember. We've got a lot of options. It's tunable. It's unicast. It's TCP based. It uses port 179 in case you have a firewall in between which you need it up, and you will see it as a test question on many exams. It's used for scalability. It's used for control. And it's used for tunability.
Just briefly to touch on what in production said. What you would actually do in this case is you would set the weight based on the peer and a prefix. You would be more granular in your actual route map that you're going to be writing, which is going to include your set and your match statements and then your prefix list. So that way that you can, it theoretically wouldn't matter which link the prefix comes through. As long as it comes on one, that's the one you would pick. If you wanted to pick a particular link, then there's other options you can also go with. But just to keep in mind, you're going to be granular when it comes to your actual policy, just to kind of give a little additional reference to what in production says there.
Yeah.
Did you want to take a couple of questions, Mike?
Yeah, let's take some questions.
Okay, let's go take some questions here. So from Raja Khan, is there a way to use attributes to ensure business or government policy of our traffic to avoid going through a certain autonomous system or a group of autonomous systems belonging to a specific country? There are. You can always do a route origin validation, which is probably the most complicated. But if you are a service provider or you own your own aggregatable space and you own your own autonomous system, then that is something that you can actually go about and doing some geo engineering, in a sense, where you kind of block out certain geographical areas. If you don't have any of those, what we generally try to go for is what we call an autonomous system access list. These are going to be based on regular expressions. What we basically have to do is we have to define what the actual autonomous system path will look like, and then filter out as the routes come in, so that we can impact traffic going out. So just so everybody understand that we can control how we go out. It's going to be difficult to control always what's coming in. So we have to set policies appropriately when it comes to that. Now, I will say this. Let's say your upstream provider, they have that customer that you don't want to deal with, and they end up aggregating their routes so that they're not sending you all the minutia of the details, basically a full routing table. If that aggregated route, or some people call it a summary route, has the autonomous system paths not correctly configured, meaning, generally speaking, whoever sets the aggregation route is going to basically remove all the details of all the other autonomous system paths that eventually the route came through. If that is the case, then it's going to be a lot more difficult for you to be able to filter out a particular autonomous system, because you would never know that it was there. You wouldn't know what is upstream unless it was given to you. Now, if they still sent you, let's say, the autonomous system paths through like an ASN list, whatever you're going to get through there, it's going to be unordered. But even though it's unordered, you can still apply your access list to it, at least your autonomous system access list, and that way you can filter it out. So those would be your general options of being able to avoid certain traffic. But just know that you need to know what to filter on to be able to actually establish the policy. If you cannot see the path, then there's nothing for you to actually filter on. You may have to go with, and this is again where route validation comes into place, and the origin of the actual routes that you get. You'll actually have to do a lookup, or who is lookup, on the IP address, and then see with whom they're registered. And if they are registered in the right country, then maybe that is another way that you can do some type of filtering.
Yeah.
It becomes a lot more complicated, that, just so you know.
Yeah.
Alrighty. And from Raj Khan, do we add the autonomous system path of our own autonomous system? Basically, do we inflate it? You want to answer this one? Because this is a funny, I'm going to give a little story about this one.
Yeah. So generally speaking, if we don't want a path to be good coming into us, we take our internet service providers and ASPath pretend their numbers, not ours. Now, if we had two links to various providers and we wanted to influence their traffic, we could actually prepend our own AS and actually send it to them. So it depends on which direction we're trying to manipulate traffic. Going outbound, we usually prepend the internet service provider's routes. And either we could, create some kind of a route map or list or something that says match these routes and ASPath prepend them. Or we could say on this link, send us a BGP community of Cindy is the cute cat. And then when we see the BGP community, Cindy is a cute cat, we automatically know to prepend the AS. So there's a lot of ways we can actually do this, but or we can look for a certain thing and manipulate it. But yes, we could add our own for outbound, or generally speaking, the provider themselves may want to prepend it ourselves if we call them on the phone. So we're doing less manipulation on their end, and they have control. But lots of ways we can do with this, and good thinking.
Yep. There is, in the videos, if you haven't signed up for it yet, the networking videos, there's actually a lab on how we're going to accomplish AS prepending. I will put it this way. If you want a lot of angry people on the internet, go ahead and start prepending somebody else's network on there and see the kind of hate mail you're going to get and them hunting you down. So general good practice is going to be you prepend only your own autonomous system. That's the best practice. And I'm going to say this as nicely as I can. Don't be the jerk that appends his own autonomous system like 10 times. Seriously, that is annoying. That becomes a pain in the neck to filter, and it's absolutely unnecessary. You could probably just add it once or twice, and you would be fine. If you need something more granular, just go with communities. Talk to your service provider, ask them what communities, which are another attribute, just so you guys understand. And by the way, communities are just tags. Think of them like tags. Tags that eventually fit a routing policy and then some type of set and match statements on what they're going to do on the other end. Mm-hmm. If you need that type of granularity and you don't want to take off a bunch of people on the internet, talk to your service provider, ask them what type of communities they actually support. And then that's another way that you can actually perhaps have them make your path to them less preferred. So that's another way you can do that.
And there's lots of ways to make this happen, but there's the way you're supposed to. But I wanted you to understand the actual protocol and how you could manipulate each way. And then Mark actually gave you the perspective of the BGP etiquette, if you will, which you both need.
Yep. Again, I don't want to say it's based on trust, but a lot of the BGP stuff was based on good faith. And it was because of people misusing this that we had to start coming up with ways on how do we protect ourselves. And unfortunately, it's only been probably within the past, we've been trying to do it past 10 years and plus, but I think it's just been recently, the last few years, where we're slowly kind of getting on the same page in regards to what are some security best practices. And that's where the route origin validation comes in, the AS path validation, things like that, that eventually couple a lot of different systems together. But right now, they're still voluntary. I know the United States is trying to make it like a mandate when it comes to BGP security. And then there's also, and I'll share it later in the chat, there's a NIST document too that describes some of the security best practices when it comes to BGP. But yeah, you can do 50 billion things with BGP. That's why people think it's complicated, because what would you say, Mike? The only restriction is your own imagination?
Yeah, pretty much. And when we're using it to propagate VLAN information, we're using it to create virtual BGP VPNs pushing through an MPLS network. I used to push it to get IP multicast source information through different internet service providers on the M-bone. We can use BGP for anything. BGP to connect to people, BGP to filter routes. Anything you can think of, if it's pretty complicated, there's usually a BGP workaround to make it happen.
All right. And just remember, guys, you can all download the videos as well. Just sign up for it, as well as the BGP guide, and it gives you also a good reference for that. All right, let's take a look at in production's question. And they're wondering, would you guys prepend your own autonomous system path if you're running BGP with two providers, basically service providers, one at 1 gigabits per second and the other one at 10 gigabits per second? If so, why? It depends.
Let's take in the scenario,
Do you want me to give them my answer first, Mike, or you want to tackle this one first?
Yeah, give them your answer, and I'll give them a different perspective, most likely, which are both going to be saying the same thing, but slightly different.
Yeah, so here again, we have to look at what would possibly give us the most consistent results. I think that's a good way of putting it. Again, because we have explicit control over how data leaves our autonomous system. That we can control 100%. It becomes tricky on how it comes back. So when we're actually using autonomous system manipulation, we're hoping that the other side is not using a more preferred attribute, thus overriding us. So that's where you have to be a little bit tricky. There's other things you can do besides the autonomous system. There's particular feature set within BGP. One of them would be to use what they call a linked bandwidth community. It's a specific community string that you have to make sure that your service provider actually supports, that you can signal towards them. And then what they'll do is they'll actually apply the policy also on their side. So that way that you have the policy basically working from both ends, and you kind of make sure that you're using for particular prefixes or and destinations a particular link. That would be something else. And then everything else would really depend on what is supported on your platform and then the BGP code that is running on that platform. But if, let's say, you just wanted to go straight nuts and bolts, believe it or not, I would actually, instead of going with autonomous systems, I would actually just use either weight or local preference. And The reason I would do that, number one, is I would need the other side to somehow override me, which means they need to use their own local preference to override what I'm doing. But at least I can be sure from my end, if I, let's say, use local preference, it gets propagated within my entire administrative domain. I can make sure from that perspective, I'm always using the proper links for my exit towards another autonomous system. So you see, that's a little bit the tricky part about BGP. You need to know what is supported from the other side, and then what can you do to keep the consistent results. Because if, let's say, you do local preference and the other side does support wait, they'll override you and you'll never know. So that's why communities have become really popular among BGP administrators and as well as network operators, because they can be signaled, policies can be written, and then they're going to get honored.
Yeah, and that's really great. I'm going to show a different side of it because Mark gave me the opportunity to talk about it technical, and I'll give you some various scenarios. And Mark, please feel free to add to my scenarios.
Yes.
So in this particular environment, this is realistically what you're asking for. Here's our own internal environment, and we're connecting to 2 ISPs via BGP. So if it's just this environment where this is my internet-facing router, all these routers just need to have if I don't know where to go to this, like I'm going to call it the IR or internet/internet gateway, whatever you want to call it. I don't care. So, and that means these routes will have a route that's going to look like 0.0.0.0/32. And what that means is if you don't know where to go to the central router. And that could be taking both links. So now once a packet gets here, if I'm running an interior gateway protocol, I can do whatever I need. I'm probably going to just change the weight on outbound links or something like that and ask the provider to do something similar with me because that's easy. Or then I'm going to change the local preference. No. This scenario changes if OSPF is my interior gateway protocol and now I run IBGP internally, and now I want to be escorting routes to, say, another provider over here, ISPC. And either I want to be a transit autonomous system, meaning traffic from here to here goes through me, and I might need to use IBGP to do that. If I wanted to become a transit autonomous system, like I'm actually an internet service provider. But if I didn't need that, I'm probably not going to pick something that's going to carry outside of my autonomous systems in a scenario here where weight would probably just be the easiest. Local preference would probably be the easiest. But if I was in a more complicated scenario, I could use something else. But in this example, it's pretty easy what we're actually dealing with. We have to understand when we're getting ourselves involved in internet providers and a point of presence, we could have 50, 60, or 100 different peering environments on a single box. And each one of those is coming in with probably about 1 million routes by now. And they're coming in with that many routes. So it's looking kind of complicated. And now if we're dealing with an IPv4 routing table and potentially an IPv6 routing table, now these databases get even bigger in the 1.6 million from, say, 100 different people. Think about that as it comes down to it. So yes, that would have been a totally appropriate way to do it. Here's probably, I would do it because it's simpler and more elegant, but yes, we could have prepended ASPF to get the job done. And it's a great question.
Yep. So for everybody, I put a couple additional references, resources for you in the chat. One of them is going to be taken directly to one of the technical documents in regards to BGP vulnerabilities. You can read up a little bit on it. They're also going to have links to additional technical documents that are going to basically either be making the current one obsolete or updating it based on some particular security mechanisms. And then the other one I added there for everybody was the actual NIST guidelines. So this is mostly for the United States, but if you're outside of the United States, still pretty good guideline, but you can also search for something comparable from the ISO, the International Standards of Organizations. And I think I can never get it right because it's International Standards and Organizations, something like that. It's ISO. You'll definitely find it, and they'll have additional guidelines to accomplish some security mechanisms as well, just to keep it a little bit simple. Let's take a look.
I can address this one.
Is that from Infinite? Okay, let's pull it. I was trying to figure out if that was a question. Let's say, so he says, from informing external autonomous systems about preferred entry points, how do we deal with ISPs whose policy may override your traffic engineering efforts, such as ISP disregarding the MET values?
So a couple of things. I probably wouldn't send my MED to my internet service provider. I'd send something else. But in every internet service provider relationship, when you're dealing with BGP, you call them and you agree to exchange information somehow. Would you like me to send me a community? If so, what community would you like me to send? Will you accept an ASPath prepend? Will you accept this? What would you like from me? Would you like me to filter routes on the way to you, except for specific ones, which you would do based upon what you need? Do you want everything from them? Do you want you can arrange that in your relationship. It's not like calling Comcast or AT&T for home internet where they just put something in for you. When we're dealing with public IP addresses and autonomous systems numbers, we're getting much more expensive internet connections. And they're going to be much, much, much more willing to go speak with us and set this up right. Because if we set it up wrong, we can take them down. So it's one of these situations in your architecture are going to speak to the internet service providers, and they're going to find out, what are you willing to accept? What are you willing to use? How do you want to make this happen? And then the engineers will make it happen. But often with a community, it's just the easiest way to do it. Because we can set any community we want, and then they can match that community and do anything we want or agree to. And it's a pretty safe way to do it. Because nobody that doesn't understand the community will be able to do anything with it. Let me go back to you, Mark.
Yeah, I was just going to add this. This is something that you really have to be involved in BGP. But what Mike said is crucial. Give the service provider or your representative a call. And the reason I say that is you can apply whatever policy you want, but if you don't know what their policies are, that's where the trouble happens. And the reason I mention that, just like you are going to have preferences for using a particular upstream provider or particular link, and we had the actual use case, right, with the different bandwidth limitations. One was 1 gig, the other one was 10 gigabit. The service providers have similar requirements. For example, if you are peered with a service provider and they're actually peering with a higher tier service provider, they're also going to choose the link which is cheapest for them based on the peering agreement that they have signed. Not every peering agreement that we go through is going to be basically a free settlement. Most of them are going to be taking some type of charge along with it. So if your service provider actually is being charged more to use a particular link, and that link might eventually bring them to you, they will, no matter what, override you. You can beg them, plead them, you can try to bribe them. None of that will work because their policies will override those. So what Mike said is crucial. Give them a call and find out exactly what their policies are. With that in mind, what I would suggest everybody is, in the near future, we'll probably have another one of these sessions. We'll go a bit longer when we can. But take advantage of the free BGP guide that you can find in the description box as well as the chat box. That's going to give you additional information. Take advantage of the videos. Like I said, that's an additional 5+ hours where we go through the explanation, not necessarily for the configuration, but rather what the outcome of the configuration is going to be. And there's going to be a lot of additional details such as IBGP rules. How does IBGP peering actually work internally with some OSPF sprinkled into it? We're also going to look at some fast failover with bidirectional forward detection. We're also going to have a little bit of a use case in regards to how do we do redistribution from BGP into an internal gateway protocol, and what are possible alternatives, and basically what are the trade-offs to doing so. And then all the different scenarios that Mike discussed with you all, that he was so kind for us to whiteboard them so that you get a visual. Just so everybody knows, architects, you're going to be whiteboarding. But in the videos, we're actually going to show you the construction of the route maps, the prefix lists, the actual filters on how they get applied. And then we actually look at the databases, both of BGP and your actual routing database, your routing information base, in regards to what the outcomes are going to be there. So there's going to be a lot of great information found with that as well. And then, of course, take advantage of the replays that you have on YouTube as well for today's session, and then the one that we did. It was earlier this year, wasn't it? If I remember correctly, we did the 6-hour marathon.
Yeah,
you
we
also
did
can
about
take advantage of
6 to 12 months. So, yeah.
Outside of that, everybody, I do sincerely hope you enjoyed the session. Make sure you join us tomorrow as well. We're going to have a fun Q&A session, but remember, by 11 a.m. Don't show up at 2 p.m. We're not going to be here. We'll be at 11 a.m. to field all your questions.
Yeah.
And then additionally, and Mike, correct me if I'm wrong on this at least time frame, on Thursday, we're going to have our how to get your first cloud architect job. And I believe that's actually going to be is it at 7 p.m., Mike? Or
7 p.m. on Thursday.
7 p.m. on Thursday. All righty. All right. Aside from that, is there anything else you would like to add?
Yeah, a couple things. So I want to make sure that everybody that enjoyed today and listened today gets the BGP book we wrote, that ebook, and gets to watch Mark's 7 or 8 hours of very good, very in-depth BGP videos. I also want to make sure that if you have any desire to become any kind of architect, we're going to discuss cloud architecture, but truth be told, if you've got questions about network architecture, security architecture, AI architecture, enterprise architecture, we'll address those on that webinar. We'll do anything we can on that webinar. You want to know why employers aren't calling you? We'll look at your LinkedIn profile and we'll tell you exactly why your interviews are not going a certain way, and you want to know if you're ready for your next interview and you want us to mini baseline you. We'll do it. It's free and it's live on Zoom. We just want you to get to your goals. So please join us if you've got any goals of any architecture careers, and join us on Thursday for that. And as a reminder, and Chris or Tyrone, whoever's behind the stage, if you want some extra intro to networking training, we have subnetting workshops on our YouTube channel. Tyrone or Chris drop a link to that. We also have a completely free CCNA course. We dropped the first 10 hours today. 20 more hours are coming this week. It's all free. We're excited about that. So my team will drop a link for that. If you've enjoyed the session, maybe give it a like, maybe subscribe to our channel and hit the bell to be notified of new videos. We've got a lot of stuff coming, and we're going to be speaking with Russ White as another network architect this week. So you're getting collections. My CCIE number is 7417. Russ is a little less than that because he beat me by 5 years on networking. Mark's here as a CCIE. So we like to give you the best we possibly can. Lots of real world network architecture experience. So hope you can give that a like. Otherwise, we ran out of time. We were going to go till 4, but it's now 4:30. So hope everybody had a good time. Give it a like. Give me a hashtag BGP so I know you're awake, alert, and oriented. And I hope to see you in so many of these webinars. My team will be dropping the link to all those links in the bottom. Take care.
Take care all.